Hi everyone, welcome back. So I have come up with a real world SQL end-to-end project that uses e-commerce dataset from Target. Now, if you don't know what Target is, so I'll quickly help you explain. So Target is a global brand, one of the biggest retailers in the US. So if you just go on their website, just search target.com, you'll be headed over to their official website. So they sell almost everything starting from groceries to shoes to clothes. They cover everything. So it's more or less like Amazon or Big Basket. So yeah, that's about the Target. Now coming back to our project, the objective of this project is to explore the data set that we have. So we have the data set of around 1 lakh plus orders, and we use SQL to extract the meaningful insights that can help Target improve operations, logistics, pricing, and even the customer experience. So overall, we have to analyze the data set, give them meaningful insights, and provide the actionable recommendations to increase their revenue and profit. So this video is divided into 3 parts. First of all, we are going to understand the dataset. Later on, we'll jump into problem statement. And in the last, we will be doing the implementation of the project in BigQuery. So without any further ado, let's begin. Let's take a look at each of the CSV files and let's see what dataset we have, what columns we have. So let's explore each of them here. So going to the order reviews CSV file, as you can see here, we have certain number of columns. Now here we have order reviews information. So here we have review ID. What review ID gives me is, which is nothing but the ID of the review given on the product ordered by the order ID. Then we have order ID, which is the unique ID of the order made by the customer. Then we have review score, which is nothing but the review score given by the customer for each order on the scale of 10. So as you can see that customers have rated that by 4, 5, 1, 3, as you can see here. Now we have review comment title. So what it gives me is this, that what is the title of the review, that okay, what exactly the review is. So here it is written I recommend, super recommended, or like that. Then we have review creation date, so the timestamp on which the review was created, and review answer timestamp, the timestamp of the review answered. Cool. Now let's move on to the second one. So if we just go on to the second one, we can see that there is order items information. So if I zoom on a little bit, okay, so here order ID is again the unique ID of the order made by the customer. Then we have order item ID, which is the unique ID given to each customer ordered in the order. Then we have product ID again, which is the unique ID for each particular product which is available on the website. Then we have seller ID, which is again the unique ID that the seller has been assigned for each seller has been assigned in the Target. Then we have shipping limit date. Now what is shipping limit date? It is nothing but the date before which the ordered product must be at least shipped. Okay. Then we have the price of the product and the freight value. Now what is freight value? So freight value is a price rate at which a product is delivered from one point to another. So this is the freight value. Now moving back, taking a look at the payments information. So here we have 5 columns. Order ID, which is very usual to understand. Then we have payment sequential. Now what is payment sequential? It is the sequences of the payments made in the case of EMI. Then we have payment type. Then we have payment installment. Now what is payment installment? It is number of installments in the case of EMI purchase. Next we have payment value. Now what the payment value gives you is, it will give you the total amount paid for the first purchase order. Okay. So that's all about the payment information. Now moving back to our orders information, let's say. Okay, so here it's very obvious with the order ID, customer ID, and order status. Then we have order purchase timestamp. So it is nothing but the timestamp of the purchase. Then we have order approved, at which the timestamp at which the order has been approved. Then we have order delivered carrier date, that means at the date at which the carrier made the delivery. Then we have order delivered customer date, that means the date at which the customer got the product. Then we have order estimated delivery date, which is the estimated delivery date of the product. So it would be easier for us that how many time. So these kind of data would be beneficial for us if we want to know that what exactly the delivery time that my product took to from shipping to delivery. Okay, so if I just go on to my next file, which is my sellers file. So if I see here, I can see, one second. So as you can see, there are 4 columns: seller ID, then we have seller zip code prefix, so which is nothing but the zip code of the seller's location. Then we have seller's city, and this is the seller's state, which is nothing but the state code. Okay, so this is the seller's information that we have. Now coming back to our to our files. Let's see the customers file. So here we have the details of the customers that we have. Okay, so this will give me the details of all the customers that we have for now. So here we have customer ID, then we have customer unique ID. Customer ID is the ID of the customer who made the purchase. Then we have customer unique ID is the unique ID of the customer. Then we have customer zip code, which is the zip code of the customer's location. Then we have customer city and customer state, which is nothing but the respective name of the city and the state code from which the customer belongs. Okay, so this is the specific customer's information that we have. Now moving on to my products information. So if I just go on to the products information, so here I have product ID, then we have respective product category, then product name length, then we have product description length, then we have product photos quantity, then product weight. So let's understand each of them here. So product ID is a unique identifier for the proposed project. Then we have product category, which is the name of the product category. Then we have product name length, which is the length of the string which specifies the name given to the product order. Then we have product description length. So it is again the length of the description written for each product ordered on the website. Then we have product photos quantity, which is the number of photos of each product ordered available on the shopping portal. Then we have product weight, so it is the weight of the products ordered in grams. Then we have product weight length in centimeter over here, so it is the length of the products ordered in centimeter. Then we have the height of the product ordered in centimeter, and this is the width of the product. So here we have the weight, the quantity, and the dimensions of the product. So it has all the details regarding the all the specific specifications of each product. Okay, so this is my geolocation table that we have. We have information about the location. So this is the first 4 digits of the zip code. Then we have latitude information. Then here geolocation longitude information. We have city information, state code information here. So that's the information that we have. So now let's just understand the problem statement that we have. So here we have been given a schema. So these are the tables that we have in our data set. This is my payments data set. This is my order products data set. Then we have orders. We have order items. We have sellers. Then this is geolocation. This is customer, and this is reviews data set. And the columns that are connecting these data sets are called as foreign keys. Now let's take a look at the problem statement. That assume that you are a data analyst or data scientist at Target. Now you have been assigned the task of analyzing the given dataset to extract the valuable insights and provide actionable recommendations. Now first step is to import the dataset and do usual exploratory analysis steps like checking the structure of the dataset and characteristics of the dataset. That will include checking the data type of all the columns in any kind of table that you can pick. Then you can just get the Next, you will get the time range between which the orders were placed. Then you can count the countries and states of the customers who ordered during the given period. In step 2, you will be doing an in-depth exploration of the orders. There you will be finding out if there is any growing trend in the number of orders placed over the past years, or any kind of monthly seasonality in terms of the orders placed, like any kind of month or any kind of peak hours of the day during which the customers mostly place their orders. So here the hours have been divided into bins of the time frames. So here dawn hours or morning hours or afternoons or night. So here you just have to find, like, is there any peak hours of the day during which the customers mostly place the orders. In the third step, you need to find out the evaluation of e-com orders in the Brazil region. There you will be finding out the month-on-month number of orders placed in each state, or how are the customers distributed across all the states. In the step 4, you have to find out the impact on the economy, where you will be analyzing the money movement by e-com by looking at the order prices, freight and others. So here what you'll be doing is you'll be calculating the percentage increase in the cost of orders from year 2017 to 2018. So here you have to include months between January to August only, and here you have been given that you can use the payment value column in the payments table to get the cost of orders. And also you have to calculate the total and average value of order price for each state, along with the total and average value of order freight for each state. In the final step, in the fifth step, you have to do some analysis based on sales trends and delivery time, like finding out the number of days taken to deliver each order from the order's purchase date as delivery time. Also here what you will be doing is you'll be calculating the difference between the estimated and the actual delivery date of the order, and here you have been given some hint that you can just calculate the delivery time and the difference between the estimated using this given formula. Also you have to find out the top 5 states with the highest and lowest average freight value, and Also, you have to find top 5 states with the highest and lowest average delivery time. Top 5 states where the order delivery is really fast as compared to the estimated date of delivery. You can use the difference between the average. So here you have been given some of the hints as well. And in the last step, you have to do some payments analysis from the payments table that you have, finding the month on month number of orders placed during using different payment types, and find the number of orders placed on the basis of the payment installments that have been paid. So this is all about the problem statement that we have. Let's now move on to the implementation part. Okay, so coming back to the implementation part, I would like to implement this project on BigQuery Sandbox. So I'm just writing BigQuery Sandbox here, and here you have to go on to this website, enable the BigQuery Sandbox. I'll also attach the link of this in the description box so that you can just access it from there. So here you just go to BigQuery. So here you can see that your console has been opened. Now I already have two of my projects, so, but I would suggest you just create a new project. I'll just help you start from scratch. So just create a new project. So this is, I'm just giving a new title. Once again, I'm just giving a new title as YouTube. Okay, and I'll just create. So what you can see is this is just creating a new project, YouTube, and I'll just select on this. Now you can see that your new project has been created. Now guys, I have attached the link of all the CSV files in the description box. You can access the drive link from there, and you can just download the CSV files from there. So you can just try experimenting this project. You can just do hands-on practice of this project with me. So just click on these three data sets, and you just have to create a data set here. So just create the data set. I'm giving my data set name as SQL, that target SQL. Okay. So this is my data set ID. You just have to give the data set ID here, and you don't need to do anything. Click multi-region US, and just create the data set. 1 second, and just create the data set. Okay. So your data set has been created over here. Now as you can see that you don't have any tables in your data set for now, and you have to upload it one by one. So you have 8 tables. So just click on three dots again. Just click on create table, and here you have to create table from, I'll be choosing the upload service here, and here I'll simply browse. And since I have already downloaded my CSV files, I'll just upload one by one. So first of all, I'll be uploading order items. So it has already detected the file format is CSV here. Now what I will be doing is I will just give my table name. So my table name is order items. So here you can give the table name based on your convenience. Now click on schema here, just auto detect, and here simply create table. Okay, so as you can see that you have your table here. Again, you have to upload similarly for all of the tables that you have to do. Just click on upload, just select the file. So here I'm doing payments file now, and here you just have to give the table name as payments. And also you have to select auto detect schema. This, you make sure that you do this. It will be very helpful for you. So again, it will be creating a table. So similarly you have to do it for all the 8 tables here. Upload, payments, orders, giving the orders, auto detect, create table. Okay, so as you can see, all of your 8 tables have been uploaded over here. So this is the customers, geolocation, order items, order reviews, orders, payments, products, and sellers table. So first of all, first step that we were supposed to do is import the dataset and do usual exploratory analysis. So now I'll just write this and checking the data structure, and this is what we were supposed to do. Okay. So first of all, select star from
from target. Okay, I want to do it from my customers. So I'm writing customers, target SQL dot customers. So if I just run this query, so you can simply click on this, simply click on run. So you can see that, one second. So this is your result. So if you want to explore, let's say I'm just applying the limit 10 so that it will only display me the first 10 records and does not go beyond that. So yeah, customer ID, customer unique ID, you have customer zip code, the zip code prefix, then you have customer city, customer state. So this is what we have in my customers data. Now if I just want to explore my target, let's say geolocation, I'll just end it by semicolon. So if I just, and I'll just apply the limit 5. Okay. Okay, so if I just run my second query, you can see that you can see all the details about the geolocation zip, as we have already explored all of these here. So that's how you can explore each of this. Now you want to see the data type of all the columns in the customers table. So let's just click on the customers table here. So here you can see the data type here. For the customer ID string, customer unique ID string, customer zip code prefix integer. So that's how there you can actually see the data type. If you want to check for order items, you can just click on order items, and here you can see this data type column here. So for each of the row that you have, for each of the column that you have here, order ID, order item ID, it is giving you the respective data type of that particular column. Cool. Now our second thing was to get the time range between which the orders were placed. So I will simply get, okay. So now to get the time range, I will actually make use of min and max function to show the earliest and the latest purchase timestamps in the order state. So in order to get the time range between which the orders were placed, I'll actually refer to my orders table. So I'm just writing select star from my orders table. This is my orders table. Okay. Now in order to, I'll just exit it by a semicolon. Okay. In order, I'll just see my orders table. So what do you have? Order ID, customer ID, order status, order purchase timestamp, and here if here we have order purchase timestamp, that could be beneficial for us, and since we want to get the time period for which the data is given, so what I'll do is I will simply do min of order purchase timestamp, order purchase timestamp, min of this column. What this will give me, it will give me the start, and second I'll do max of order purchase timestamp, and it will give me the end time. So what it is giving me is, it is giving me the time period for which our data is being given to us. So if I just run this query, what you can see is, wait, this. Okay, so this is my start time and this is my end time. So if I just write the insights, somewhere my start time is actually 2016-09-04. That is from 4th of September 2016 to 17th of October 2018. So this is the time range between which the orders were placed, and this is the data that we have been given. Okay. Next, what we were supposed to do, we wanted to count the cities and states of the customers who ordered during the given period. So this is the third thing that we have to find out. Hold on a second. Okay. Now, in order to count the cities and states of the customers who ordered during the given period, I'll have to refer to the customers table, right? So basically here I'll have to join my orders table as well as my customers table. So I'll apply the join clause in on both of these tables on a common column. So if I just go back and refer to my schema, so this is my customers table here, and this is my orders table over here, and this is the customer ID that is actually joining it, which is behaving as a foreign key. So I'll be joining my orders table as well as my customers table on the basis of my customer ID key. Cool. So let me just write my query. So select from, first of all, I will writing my orders table, orders. I'm just giving it as alias O, and I'll just do an inner join on my customers table. Okay, and I'm just giving this as alias C. Now as C. Now I'll be joining this on O dot customer ID is equal to C dot customer ID. Cool. And here I have to apply the condition that since I want to count the cities and states of the customers who ordered during the given period. So this is my condition that the order should be during this period. So I'm applying where. So let's say I am just defining some certain period. So here, since we have not been given any kind of period over here, so I'm just defining it on my own. Let's say the year from order purchase timestamp. So O dot order purchase timestamp. Okay, here I will be extracting that. Let me extract this. This should be, let's say, 2018, and I have specified that year should be 2018, and I'll also specify the month. That month should be from January to March, let's say. Okay, so month from order purchase timestamp. Again, I'll be extracting month. Extract month should be between 1 and 3. Okay, so this is going to be, and what things that I need to extract. I want to extract the customer count the cities and states. So here I just want to extract the cities and the states. So customer underscore city, comma, customer underscore state. Customer underscore state. So this is from my customers table. That's why I'm writing C dot and C dot. Okay, cool. So if I just run this query, I'll get the results as customer city and the customer state. So I have only got the details of those customers who have ordered during this particular period. Okay. So to do that, I had to do a simple inner join on my orders table and the customers table. So just write the display the cities, display the details, because I'm not counting it here. Okay. Now let's on to my next question, that is there a growing trend in the number of orders placed over the past years? So this is going to be my next question. So what I'm going to do is like, is there any kind of seasonality with the peaks at some specific months? So here what we will be doing is what would be our methodology to solve this problem would be, we will be selecting the month and the count of order ID from the table, and we'll group the data by month. So basically what we need to find here is that we just need our output to show the number of orders made each month, right? So that it will be easier for us to find out that which month has got the highest number of orders. If we can find any month having the highest number of orders, that means in that case that month is actually performing well, and and the best part is we can even sort that in the descending order by the count of the order numbers. So that we can clearly visualize that which month is performing the best and which month is not performing the and which month is performing the least. So in order to do that, what I just told is just from the orders table. So if I just see my orders table, this is my orders table. Okay, so these are the columns that I have in my orders table. Now what I will be doing is I will simply extract month as a new column. Okay, I'll simply extract month as a new column, and then I'll just apply the group by on the month on that new column that I just extracted, group by on the month column, and I will be applying the count of orders. That is nothing but the aggregation on the count of orders. So let's just do that. Okay, so what we will be doing is we will simply write my query from, I'll refer to my orders table here. So what I'll be doing is I'll be simply extracting the month. Okay, extract month from order purchase timestamp. Order purchase timestamp as month. Now I will do it. I'll apply the group by on this extract month. 1 second. Okay, I'll apply group by on this, and also I will be applying the count of order ID. Why? Because I want to count the number of orders for each specific month. So it will give me order order number. Okay, and at last I'll simply apply the order by clause on my order num column, and I'll make sure that it is in my descending. So if I simply run this query, what I will be getting is I'll be getting the month and the order number. So as you can see here, month 8, that means August is the month having the highest number of orders, followed by the month of May. Okay, so August is performing the best. August and May. So these are the insights that the number of orders is highest in the month of August and May. In August, we have number of orders is 10,843, and in the month of May, we have 10,576. And relatively, July is also performing very well, having the number of orders is 10,330. Okay, so we can assume that the reason of having of this peak number of orders could be like any kind of a reason, could be national holiday or any kind of winter seasons. Now coming back to our analysis, we have the next in our pipeline, which is, can we see some kind of seasonality in terms of the number of orders being placed, as we already done this, because seasonality is that monthly seasonality is that the month of August and the month of July is performing well. Now this is going to be my next question to be solved, that during what time of the day do the customers mostly place their orders. Now again, since we have to analyze the orders, so again we will be referring to the orders table here. Now, in order to analyze how the customers buy, what we will be doing is, again we will be extracting R from the order purchase timestamp. In the above case, we extracted month, but in this case, we'll be extracting R. So let's just extract that. I will simply write the same query again. I will simply extract R as time, and here I will simply write as time. Okay, and this is going to be my count of orders or order ID group by. Here I'll simply write R from this order by on num descending. I'll simply close the above query, and if I just run this query, what I'll be getting is, just go and see the results. So you can see we have been given the time here and as well as the order numbers based on these timings. So if we actually see the complete patterns, we actually see the patterns here: 16, 11, 14, 13, 15, 21. That is almost highest number of orders in the afternoon hours. So these are my afternoon hours. 16, that means 4 o'clock, something like that. So we can say that Brazilians tend to buy in the afternoon than morning time. So this is more or less the early morning time. 3, 4, 5, definitely they will not be buying this early. And followed by, they, like, what we can say is So insight here is that Brazilians tend to buy in the afternoon and the morning time. Now moving on to our next analysis, which is get the month on month number of orders placed in each state. So let's write the SQL query for the same. So here, to solve this problem, what I'll be doing is, I'll be extracting the month and year from my order purchase timestamp column using the extract function. And then I'll simply count the number of orders placed in each month using the count function. So, so let's do that. I'll be referring to my orders table again. So I'll be, one second. I'll simply write third, which is get month on month orders. Okay. So let me simply from orders. I'll simply run this and see. So here what I have to refer to, one second. Okay, so here I will be referring to my order purchase timestamp column. Okay. And from this order purchase timestamp column, what I'll be doing is I'll be simply extracting the month and year, and I will apply the group by operation on these month and year specifically, and then I'll simply count the number of orders. So in that case, it will give me the month on month number of orders. So let's do that. So select, I'll simply extract. What I'll be extract? I'll extract month from order purchase timestamp. So this will be extracted as my month, and similarly I'll be doing it for the year. So here I'll write year. Okay, and I'll simply close this as year. So these is going to be my third column, and I have to do group by operation on year comma month. I mean the column that I extracted. One second. Okay, and yeah, I will also apply my aggregation function, which is my count star. So count star is going to be my number of orders. So num orders. Okay. So based on this aggregation, I'm simply counting number of orders for each month and the year that I'll be able to see here. Now, at the last I'll simply do order by on the year, comma month. So if I just run this query, let's see what I get. So these are your results. So for the month 9 and the year 2016, your number of orders were 4, and it's on. From 2016 here 9, 10, 12, then 1, 2, 3, 4. So this is January 2017, this is February 2017. So by this, so like this, you are getting the number of orders. Uh, you're getting the month on month number of orders. So for this month, these are the number of orders. So like this, you can simply do that. So what we did is, so I'll quickly explain what we did is, what we actually made use of extract function. So this is your extract function to extract the month and specific year from the order purchase timestamp column that we have in my orders table. And then we have counted the number of orders placed in each month using the count function. So count star function is nothing, is actually counting the number of orders here. So and here we have applied the group by clause to group the data by year and month so that the results are aggregated by month. And finally, we have simply sorted the results in ascending order by year and month using the order by clause. So this was my solution. Let's now move on to see the next analysis. So here we have to find how are the customers distributed across all the states. So in short, you have to do, so in short, so third it was 1. Okay. Now what you have to do here is that you have to find the distribution of customers across the states of Brazil. So what do you want to see in your output? You simply want to see the customer count based on each state. So you should be having two columns here in your output. One column should specify the specific state, and the other column should specify the count of the customers in that state. So that's how you have to see your output. Now, in order to solve this problem, we will be definitely referring to our customers table, because here we will be getting the information of the customers. And in order to find the number of customers for each state in Brazil, we will use the column. So let's see what columns do we have from our customers table. So if okay, so here we have customer ID, customer unique ID, customer zip code, customer city. So this is something that we will be referring. No, we will be referring to customer state. Okay, so we will be referring. So here in this question, we will be using the column customer state and the customer ID. So customer ID will be using to actually count the number of customers from the customers table, and we will simply group the data by customer state, because as you can see there are so many customers in single state. So this is AC, so you can see there are so many customers in a single state. Okay, then we have another state which is KL, and it will go on like that. Okay, so let's just write the query now. So our approach to solve this problem would be that we will be using the customer state and the customer ID column from the customers table, as we just explored. And here we'll be applying the group by clause on the customer state. Then we will simply use the count function to count the number of distinct customer IDs, so that we'll be getting the distinct customer count. Okay, so that it will make sure that you don't have the repeated customers counted again and again. So let's write the query. Select. Here I will be referring to my customers table. So this is my customers table. And here what I will be doing is, I just want to see the customer state, comma, and here I will be I'll count the number of, okay, it should be distinct customer ID, okay, and this will be my customer count column. I'm just giving the alias as customer count. And since we have used the aggregation function, we'll have to definitely apply the group by clause. So I'll be applying the group by on customer state. So make sure that whenever you use aggregation function like sum, count, min, max, and all of that, so the columns that are not aggregated always come in group by clause. So here we can see that the customer state column is non-aggregated column. So this will come under group by clause here. Okay. And at last, we will simply apply the order by clause on the customer count. Let's see. I just want to see the highest customer count at the top. So I'm just applying descending. So if I just run this query, let me see what I get. Okay. So as you can see, you have the customer state as well as the customer count displayed over here. Even if let's say I wanted to display the customer city as well. So customer city, customer state. Here I had to apply the customer city. So if I just run this, okay. So yeah, as you can see, this is, I guess, more clear, because we have mentioned the customer city. So this city has the highest number of customer count, and this city, one second, and this city having the lowest number of customer count. Okay. Let's now move on to our next analysis that we have. So we want to find the impact on economy. That is, we want to analyze the money movement by e-com by looking at the order price, rate, and others. So here what we have to do is, we want to get the percentage increase in the cost of orders from year 2017 to 2018. We have to include months between January to August only. And it's also written that you can use the payment value column in the payments table to get the cost of orders. Okay, so here we have been given the hint that you can make use of the payment table. Cool. So let's see the payments table. What do we have in the payments table? We have order ID, we have payment sequential, we have payment type, payment installments, and payment value. Cool. So, and it was mentioned that you can use the payment value column in the payments table. So this column is useful for us. So let's now move on to write the query. So now let's discuss how we'll be approaching this kind of question, where we want to calculate the percentage increase in the cost of orders from year 2017 to 2018. Cool. So basically what we will be doing here is we'll first join the payments table with the orders table, and then we will simply extract the year and month from the order purchase timestamp column, and then later on we will simply filter for only since we only want to include the months between January and August in 2017 and 2018. So basically we'll simply apply the where condition that we only want to include the months from between January and August. And next we will simply apply the group by on year, and then we'll simply calculate the sum of the payment values for each specific year. Let's say for 2017 and 2018. And then since we have to calculate the percentage increase in the cost, we will use the lead function to compare the payment value between 2017 and 2018. And finally, we'll calculate the percentage increase by dividing the difference in payment values by the previous year's payment value and multiplying it by 100. So that's going to be my methodology to solve this problem. Cool. So our methodology to solve this problem is going to be something like this: that we will first calculate the total payments per year. So basically we'll be definitely filtering the results only for the duration, that is January to August. Okay. So here what we'll doing is we'll simply calculate the total payments per year. Then later on in the step 2, we will simply use the lead function to compare each year's payments with the previous year, so that it would be easier for us to understand the payments in the 2017 and in 2018. Okay. Next, what we'll be doing is we'll simply calculate the percentage increase. So this is going to be a step 3. Where we'll simply calculate percentage increase only for years where comparison is possible. Okay. So let me just write my steps. So my step 1 to solve this problem is going to be that I'll calculate total payments per year. Okay. Then my step 2 would be to use lead window function lead window function to compare each year's payments with the previous year. Okay. And in the final step what I'll be doing is I'll simply calculate percentage increase only for percentage increase, which since I only want to calculate the percentage increase in the cost of orders from the year 2017 to 2018. So let's simply write the query here. So first of all, in my step 1, let me write my query. So here I'll be referring to my payments table first, from payments. Okay, payments. I'm giving it as alias P. And I'll join this payments table to my orders table. Okay, and I'll give it as alias O. Okay, so this join will happen on order ID column because that is the common column that we have. So this is going to be P dot order ID is equal to O dot order ID. Okay, so if you see the payments table here, so this is the order ID that we have in common, and here this is your order ID that we have in common. Okay, now cool. Now what we have to extract, we want to extract year. So let me write extract year from order purchase timestamp, right? So I'll simply write order purchase timestamp. So this I'll take from my orders table. So I'm writing o dot order purchase timestamp. Now what it is going to be? This is going to be a year. Now next, what you want? You want the sum. You want the sum of payment value, right? So I'll be referring to my payments table. So P dot payment value, and it will give me total payment. So it will give me total payment. Cool. So let me simply run this query, what it gives me here. And here you have to apply the group by on, this particular column. Extract year from this. Okay, So if I just run this query, okay, so let's see. Okay, so let's see what this query will give you simply. So this query is giving you the year and the total payment. Okay, but you want to have only for 2017 and 2018, and that too between the month of and that too between the month of Jan and August. So we have to apply that filtering condition over here. So here I'll write where my extract this year should be this year should be in 2017 comma 2018. So this will filter only for 2017 and 2018, and similarly I'll do for month. So here I will write extract month. Now what should be month? Month should be between 1 and 8. So for January we are writing 1, and for August we are writing 8. Okay, cool. So let's see what this query will give me. Okay, so as you can see here, it is only giving you the results. So here 2017, 2018. So this is going to be your total payment value. And in 2017, in 2018, definitely it was much higher, as you can see here, the figures. So we want to calculate the percentage increase now. So I'll just enclose this in my CTE. So I'm just giving it as yearly totals. Okay, just giving the CTE name as yearly totals, and I've enclosed this in my CTE. Okay, so now from this particular CTE, what you will be doing is, let me just write from yearly totals. Okay, now from this particular CTE, what you want to do is you simply want to use the lead function to compare each year's payments with the previous year. So you want to write year comma total payment comma, and here you just apply the lead function on the total payment column. Over here you simply apply the order by year, and just write here descending, and this is going to be your previous year payment. Okay, so this is your step 2. Now in the final step, you have to calculate percentage increase. So here I'll simply write select from yearly totals, and I'm referring to my second I'm referring to okay, so again you have to create this particular CTE. So here this should be your again the CTE name, so I'm just giving the CTE name as yearly comparisons. So I'll enclose the step 2, this particular query again in a CTE. So this is your yearly totals. Okay, so now you have to refer to this. Now you have to refer to your this CTE, the second CTE, which is yearly comparison. Just yearly comparison. Now from this, you want to calculate the percentage increase. Okay, so if I simply run this query, let's see what do we have in our yearly comparisons table. So if I just run this query, you can see that we have 3 columns over here, that is year, then total payment, and the previous year payment. Now what is we simply want to calculate the percentage increase now. In 2017 we have this, in 2018 we have this. Now in order to calculate the percentage increase, I have made use of lead function in the second step, so that I can have this in my same row. So I have applied lead, and by using the lead window function, it has come here. Now in order to find the percentage increase, what I'll be doing is I'll be subtracting this total payment minus previous year payment divided by previous year payment into 100. So that's what I'm going to do. Divide by previous year payment into 100. So that will actually give me the percentage increase. So here what I will be doing is total payment minus previous year payment. So this has been subtracted, divided by, okay, divided by previous year payment. Okay, okay. Now you will be writing into 100. So it will give you the percentage. And if you also want to apply the round, you can simply show some syntax error. 1, 2, 3. Okay. Total payment minus previous year payment divided. I run this query now. This is going to be my final query. Okay, so if I just run my final query now, you can see that it's giving me 136.98 percentage. So by this, that means it has increased more than 100%. So by this percentage, we can see that there is percentage increase of 136.98. So let's now move on to our next analysis that we have. We want to calculate the total and average value of order price for each state. Now in this case, total means sum and average means mean. So what we have to calculate? We have to calculate the mean and sum of price in flat value. And in the next analysis, we have to do the similar thing for the flat value for each state. So similar thing that we have to do, that we have to calculate the mean and sum of price and freight value by customer state. So let's write our next analysis now. So I hope this was clearer to you. So in the next analysis, we want to calculate mean and sum of price and freight value by customer state. So let's just explore the columns that we have. So let's just explore the tables that we have. We have the orders table. So here then we have order items. So in the order items table, we have freight value. So this is going to be useful for us. The order items table is going to be useful for us. Let's now move on to our customers table because that is again okay. So basically we have to find mean and sum of price in freight value by customer state. So basically what we have to do is we have to refer three tables over here. One is the orders table, second one is the order items table, and the third one is the customers table. Now why? Since we want to retrieve the average and sum of price and freight value for each customer state by joining three tables, so we will be using join statements to combine these three tables based on their common IDs. And then we'll simply group the results data by customer state using the group by clause. So this question is very easy. You simply want to identify the which tables we will be using. So moving on to the customers table, here the customers table will be making use of since we want to identify for each customer state, we want to consider the customer state. So we'll be making use of the customer table. We will be making use of the order items table because we have the price and with flat value here only. So here we'll simply apply the average and sum clause, average and sum operation on both of these columns, that is price and freight value. So yeah, we'll be referring to the order items table and the customers table. So I guess these two tables should make sense to us. So let me simply write. So select from. So let's connect the order items as giving as alias OI, and I'll simply do inner join. To my customers table. Customers as C on C dot. Yes, we have one second. Order items. We have order ID here, and since we have order ID, and if we just move on to the customers table, we have customer ID. Okay, so first of all, I'll have to join order table to my order items table because we don't have any common column here. If we just take a look at the schema, so this is my order items table and this is my customers table. So I cannot directly join my order items table to my customers table. I'll have to join it using my orders table, which is this. So that's why I'll have to join three tables here, because I cannot directly join my order items table to my customers table. I don't have any direct connection to it. So my indirect connection is possible only through my orders table. So I'll simply join my order ID table to my orders table using the order ID column, and then I will join my orders table to my customers table using customer ID column. In that case, I'll be able to make a connection between my customer table and the order ID table. So let's go back again. So here I'll first write my orders table. So this is going to be my orders table, giving it as alias O. Then I will be joining in to my order items table. Okay. And I'll give it its alias OI. And I'll be doing it on my order ID column because that is the common column that I just saw. So OI dot order ID. Now I will again do a inner join on my customers table. So that is left. So this is going to be my customers table, giving it is alias C, and I'll be doing it on my customer ID columns. O dot customer ID should be equal to my C dot customer ID. Cool. So I have joined my tables. If I simply do select star, oh my god, it's going to be huge. But let me just run. Oh my god, execution time is just getting longer. Okay, let's not run this. Okay, it is execute. So this is how it is connecting my three tables over here. Now what do I want to compute? What I want to compute is I want to compute the customer state from my customer table. So this will come from my C dot customer table. Next, I want to compute the average of price. So average of price as my average price. Average, so mean and sum of price. So this is my average price. I'll compute sum of price as well. So sum of price as my sum price. Okay, comma, comma. Next, I'll calculate the average of rate value. So, okay, rate value as my average rate. If you guys wondering what is rate value, so it is nothing but cost of transporting goods from seller to customer. Okay, it usually represents the shipping charges. So this is going to be your average rate, and here you want to do the sum of rate value, FREIGHT, rate value as sum of rate. Okay, cool. So these are the things that now you have to definitely do group by clause. So group by should be applied on your non-aggregated column, which is only left. So this is your customer state column. Okay. So this is going to be my final query. So if I just run this query, let's see what it gives me. Okay, so based on each state, it is giving you the average price, the sum of price, the freight value, the sum value, and like that. You can also round it to 2 decimal places. So I'm not doing it for now. And I'm just giving you suggestions so that you guys do it on your own. So now we have to do analysis based on sales, freight value, and the delivery time. So only these many questions are left. Okay. So here we have to find the number of days taken to deliver each order from the order's purchase date as delivery time. Also calculate the difference in days between the estimated and actual delivery date of an order. And we have to do it in a single query. Here we have some hints that you can calculate the delivery time and the difference between the estimated and actual delivery date using the given formula, that is time to deliver is equals to order delivered customer date minus order purchase timestamp. And also difference in the estimated delivery could be calculated as order delivered customer date minus estimated delivery date. Okay, so here we have some of the formulas. Cool. So let's just write the query. What we have to do is we have to calculate the days between purchasing, delivering, and estimated delivery. So basically, this is what we have to do. Number of days taken to deliver each order. So this is your delivery time. Number of days between delivering. Here we have to calculate the days between estimated delivery and actual delivery. So here in short, I will simply write this complete question as calculate calculate days between purchasing the order, delivering the order, delivering and estimated delivery, because that's only going to help us in our analysis, right? We want to calculate the difference in these. So similar thing I'm doing it. So there are so many methods to solve a single question. You can just try on, you have the data set, just try on writing SQL queries, try multiple methods, and just do the analysis on your own, like, and in at the last you have to give some of the very beautiful insights and the recommendations that you can give. So I'm just doing on my own here. So again, what I'll be referring to my orders table, because I have the order purchase timestamp, delivered, customer delivery date, and the delivery date. So I have the complete order status information in my orders table. So I'll be making use of my orders table. Then I'll make use of my order items table again. Why? Because I have shipping limit date here. So in order to solve this problem, we have to definitely reference to our orders table, because we have all the details of the order status over here. As we can see, we have order purchase timestamp, order delivered carrier date, we have order delivered customer date, as well as order estimated delivery date. So everything that we want to include. Okay, so I simply want to refer my orders table, so I'm just writing it that way. Now moving on to our question here, as you can see, we simply want to calculate the number of days taken to deliver each order from the order's purchase dated as delivery time. So these two things that we want to calculate, so time to deliver and the difference in the estimated delivery. Okay, so here we have the formula order delivered customer date minus order purchase timestamp. So I'll simply write this formula over here. Cool. So in order to do that, I'll make use of date diff function. Okay. So what date diff function will do, it will date of and it will be from my orders tables definitely. So it's order. So I'll subtract order delivered customer date. Customer underscore date. I guess it's that only. Okay, this is order delivered customer date minus order purchase timestamp. So I'm calculating the time to deliver minus I'm simply doing date diff this comma date of order purchase timestamp, right? Order purchase timestamp. Cool. And this I want to write comma day. And I want to see the number of days between these timestamps. So it should be my days to delivery. Cool. So this is going to be, I must write it in my select class. And the next one, and here I want to write the order ID, because I want to extract the order for specific order IDs only. And the same thing, I'll be using the date diff function again. On my order estimated deliveries, it's going to be, so here I'll be writing estimated order delivered customer date. No, it should not be ordered Okay, yeah, it should be order delivered customer date minus not order purchase timestamp, but it should be order estimated delivery date. So here it will be order estimated delivery date as, and this is going to be your difference in the estimated delivery. Cool. And yeah, I guess that's your query. If you just run this query, let's see what your output. Okay, so this is going to be your output. For each specific order ID, you have the number of days to delivery and the difference is the estimated delivery. So you can see there is minus 17. So if you just remind the formula, we have the estimated delivery, difference in the estimated delivery formula was order delivered customer date minus order estimated delivery date. So if in case your estimated delivery is greater than 0, that means if your estimated delivery is coming positive, that means your order delivered happened late. Your order got delivered late after the estimated date. But if in case the estimated delivery is negative here, that means your order got delivered early. So here in this case, your order got delivered 17 days early, okay, earlier than estimated. And here, if it is written minus 29, again, it got delivered 29 days earlier than estimated. Then here we have 12 days, that is in the positive sign. That means the order got delivered 12 days later than estimated. So that's how you can make your analysis. So the next analysis that we have is that we want to find out the top 5 states with the highest and lowest average freight value. Okay, so basically here you want to have the information regarding the freight value and the states. So in order to get the information of the freight value, you'll go to the order items table, and here you have the information of the freight value. Now, you also want the information of the customer state, right? So in order to have the information about the customer state, you will have to refer to the customer table, and here you have the information about the customer state. Now, again, the problem is that you cannot directly connect customers table with the order reviews table. Again, you'll have to make a connection, making use of the orders data set. So here you will be joining again the three tables, that is order items table, the orders table, and the customers table. And these are the common columns, order ID and the customer ID. Based on these columns, you'll be making this join. So let's do that. So first of all, what I'll be doing is I will be doing join. So let me just finish my above query using a semicolon. So first of all, I will be writing. So I'll be writing my orders table. So this is my orders table. I'm just writing it as O. Next, I will do the inner join, and I will be doing it with my order items. So this is my order items. I'm giving it as alias OI, and I'll be doing it on my order ID column, right? Order ID is equal to OI dot order ID. Cool. Now again, I will be making the join on my customers table. So this is going to be my customers table, and and giving it as alias C. Cool. On my O dot customer ID, which is my foreign key. So customer ID is equal to C dot customer ID. So this has happened. Now what you have to do is you want to find the freight value. Okay. So I will be writing average. That should be average. So I'm making use of average of freight value. And so it will give you average freight value. Cool. And also you want to write the customer state. And here, since you'll have to apply the customer state from your, okay, so here you'll be applying from your customers table. Okay, customers table, and at last you have to apply your group by clause on your customer state. And at last here just apply the order by on your average freight value. Okay, and it should be in the descending order. So since you want to find only the top 5, so I will be applying the limit. So I'll be applying the limit here. So I will write limit 5. I hope you're clear with the query. So if I just run the query, I'll quickly explain what we did here is we have joined 3 tables in the data set. One is the orders table, second is the order items table, and third one is the customers table on the respective foreign keys. Okay. And then we have applied the group by clause to group the results by customer state. And we have calculated the average right value for each state using the average function here. And finally, we have sorted the results in the descending order by average rate value. And we have applied, since we want to calculate the top 5 states, so that's why we have done the descending order so that the top value appears at the first. And then at the last, we have simply applied limit clause to actually limit it to the top 5 states. So running this query, let's see what it gives us. So you can see these are my top 5 customer states and the respective average rate value. Okay. So this is my insight. Okay, so my next question is find out the top 5 states with the highest and the lowest average delivery time. So again, this question is quite easy. I'll again make use of the customers table, the orders table, and the order items table, and I will be referring to it is giving you the average delivery time. So as you recall, we have recently calculated the delivery time, okay, days to delivery, which is by subtracting the delivered customer date minus purchase timestamp. So it's giving me it will give you the time to delivery, and then you can simply apply the average function on the top of that. So it will give you the average time to delivery. Okay, so we can do it again if you want. I am making use of this, writing this. Since what do you want from here is that you want customer state and the highest and the lowest average time to delivery, right? So here, in order to get the time to delivery, I'll be writing extract function. I'll be doing it. Before we did it using date diff, but let's do it from extract this time. Extract date from, so I'll be doing it from my delivered customer state, sorry, customer date should be minus, again, extract, and I'll be extracting date from, should be o dot order purchase timestamp. Cool. So it will give you average, and you have to apply average on the top of it. So just apply the average here, avg on the top of it. Just close it here. So this will give you the average time to delivery. Cool. So these are the columns that you want to extract, the first column and the second column. And here in the order by, you have to do average of time to delivery, should be in the descending order, and you want to since extract the top 5 states, so we'll be writing top 5. Close it. So if I just run this query, let's see what it gives us. Okay, so these are the customer states, and this is the estimated time to delivery over here. So this is the actual timestamp, and these are the number of days: 28, 28, 26, 24, 23. So that's how it's coming along. So these top 5 states with the highest and the lowest average delivery time. For if you want to do it for the lowest, you can simply write the ascending here. And then it will give you the top 5 states based on the, so yeah, that's how you can simply you can simply calculate for the highest and the lowest. If you want to calculate for the highest, you have to use the descending. If in case you want to calculate for the lowest, you will have to make use of ascending. Cool. Moving on to the next question. The next one is very obvious. You can calculate it on your own. Let's move on to the sixth one. Find the month-on-month number of orders placed using different payment types. Now find the month-on-month. So here we have the payment type analysis question. So here what you have to do is you have to find the month-on-month number of orders placed using different payment types. So here you will have to make sure that you refer to the different payment type of options. So here you'll have to definitely consider the payments table. So here you have the payment type column. So that could be useful here. So what you'll do is you'll simply join the orders table and the payments table on the common column, that is I guess the order ID, and then you'll simply group the results by payment type, year and month, right? Payment type, year and month, and then you'll you just need to do order the results by payment type, year and month, and you can simply calculate the count of the orders. So this is going to be the very easiest question, very easy question. We have done the similar way before. So let's do it again. Select from, I'm writing the orders table here, orders table, and it should be the alias as O. Then I will be doing it the inner join, that is again the join only. On my payments table it will be P, and I'll do it on my order ID column, P dot order ID. Cool. And here I will be writing group by. And okay, now what exactly do you want to extract? You want to extract the payment type as I already discussed. Next you want to extract, once again, okay, next you want to extract year from order purchase timestamp, order purchase timestamp, and it will be your year, because that's how you will be calculating the month on month number of orders placed. So number of orders placed, so order purchase timestamp would refer to the number of orders placed at that time. Okay, so you'll be extracting year. Similarly, you will be extracting month as well. So just write month, and you'll be writing here month. Okay, so just apply comma, and based on that, you have to count. You have to do a simple count of distinct order IDs. Now why distinct? Because it should not count the duplicate values. It should only count the unique orders. So I'm writing order count here. And yeah, definitely I'll have to apply the group by clause on my payment type column, as well as my year column, as well as my month column. At the last, you have to do order by on the payment type, then year, comma, month. So let's run the query. Let me close the above query. Oh, it shows some error. What kind of error? Expected end of output. Okay, there should be comma. Cool. Column name order ID is ambiguous. Which order ID is it referring to? Order ID will be from O dot order ID. Let me run this again. And yeah, you can see the payment type UPI, and here you have the respective year, the respective month, and here it is giving you the complete order count of that particular payment type, year and month. So that's how you can calculate like this. So moving back to our next analysis, we have to find the number of orders placed on the basis of the payment installments that have been paid. Okay, so here what we have to do is, it's going to be again very easy code. You just have to calculate the count of orders based on number of payment installments. Again, you'll have to refer to the payments table here. So let's do that. So in order to do this, what we'll be doing is we simply need to analyze the frequency of orders based on the number of payment installments. So so what we'll be doing is we will be making use of the payments table only here. Select from payments table, and from the payments table you just have to extract the payment installments column and just do the count distinct of order ID. I hope you have order ID in your payments table. Yeah, we do have order ID. Order ID, and it will give you the number of orders. And you'll be writing the group by clause on the payment installments column. So yeah, that's going to be your final query. Let me end above query using a semicolon. Cool. So if you just run this, you can simply, what is the error now? Okay, cool. Okay, so this is giving you the number of orders based on the payment installments. 0 installment, 2 orders. 1 installment, these many orders. So that's how you can do your analysis. So that's all for this project. That's all these all the questions I wanted to analyze. These all the analysis I wanted to do. So that's all for this video, guys. I hope you enjoyed the project. You can also this is an industry level project, so definitely you can consider it mentioning in your portfolio or resume. So if you're applying to e-commerce companies or the retail companies, this project is can definitely help you. So that's all I wanted to share in this video with you guys. I hope you liked the video. Please like the video and subscribe to my channel, and also share your comments if you want, or also share your comments if you think there are any different approaches to solve any of the analysis. Just share in the comments. And thank you, and see you soon. Bye bye.